Alright, so in this problem, I have x to the power of 21 plus x to the power of 14 is equal to 36. So I'm first going to rewrite this as x to the power of 7 times 3 plus x to the power of 7 times 2 is equal to 36. Now, I'm going to put this as x to the power of 7 to the power of 3 plus x to the power of 7 to the power of 2 is equal to 36. Now I can let x to the power of 7 equal to the variable y. So now I have y to the power of 3 plus y squared is equal to 36. Now if I subtract 36 on both sides, these two cancel out, and I get y to the power of 3 plus y squared minus 36 is equal to 0. Now negative 36, I can rewrite this as negative 27 minus 9. And now I can rewrite this as y to the power of 3 minus 3 to the power of 3 plus y squared minus 3 squared is equal to 0. So if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. And if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, I can rewrite y to the power of 3 minus 3 to the power of 3 as y minus 3 times y squared plus 3 squared plus 3y, plus I can rewrite y squared minus 3 squared as y plus 3 times y minus 3, and this is equal to 0. Now if I factor out y minus 3, I get y minus 3 times y squared plus 9 plus 3y plus y plus 3. This is equal to 0. And this simplifies into y minus 3 times y squared plus 4y plus 12 is equal to 0. So this gives me two equations. Y minus 3 is equal to 0, which means y equals 3. This is one solution. And y squared plus 4y plus 12 is equal to 0. So to solve this, we have to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac over 2a. And I'm not going to waste your time actually plugging them in, but if you do, you end up getting that it's less than 0, so this won't work out. So y equals 3 is my only solution to this equation. Now remember how we let x to the power of 7 equal y. So now I have x to the power of 7 equal 3, meaning x is equal to the 7th root of 3. Alright, so in this problem, I have x to the power of 6 minus x to the power of 3 is equal to 2. So I'm going to first start by subtracting 2 on both sides. So now I have x to the power of 6 minus x to the power of 3 minus 2 is equal to 0. Now I'm going to rewrite x to the power of 6 as x to the power of 3 squared. Now I have this minus x to the power of 3 minus 2 is equal to 0. Now I'm going to let x to the power of 3 equal to the variable y. So now if I substitute in x to the power of 3 for y for x to the power of 3, I get y squared minus y minus 2 is equal to 0. So now I'm going to factor this by rewriting this as y squared minus 2y plus y minus 2 is equal to 0. Now I'm going to factor by grouping, so I have y times y minus 2 plus 1 times y minus 2 is equal to 0. So now if I factor out y minus 2, I get y minus 2 times y plus 1 is equal to 0. So this gives me two equations. Y minus 2 is equal to 0 and y plus 1 is equal to 0. For y minus 2 equals 0, y equals 2, and for y plus 1 equals 0, y equals negative 1. Now remember how we let x to the power of 3 equal y. So now I have x to the power of 3 is equal to 2, and x to the power of 3 is equal to negative 1. So for x to the power of 3 equals 2, I can simply take the cube root on both sides. So now I have x is equal to the cube root of 2. And for x to the power of 3 equals negative 1, again, I'm going to take the cube root on both sides. So I get x is equal to the cube root of negative 1. And the cube root of negative 1 is simply negative 1. So I have x is equal to negative 1. So these are my two solutions to this problem. Alright, so in this problem, I have x plus 100 squared is equal to 2x plus 199. So to solve this, I'm going to first start by rewriting 199 here as 200 minus 1. So now I have x plus 100 squared is equal to 2x plus 200 minus 1. Now from here, I can factor out 2 from 2x plus 200. So now I have 2 times x plus 100 minus 1. Now I'm going to let the variable a equal x plus 100. So now if I substitute in a for x plus 100, well, we have x plus 100 over here and x plus 100 over here. So now I have a squared, I'm simply just substituting in a for x plus 100, is equal to 2 times a minus 1. And this is the same thing as a squared is equal to 2a minus 1. Now, I'm going to go ahead and subtract 2a and add 1 on both sides. So then these two cancel out, and now I'll be left with a squared minus 2a plus 1 is equal to 0. Now a squared minus 2a plus 1, that's the same thing as a minus 1 squared. So this is equal to 0. And now if I take the square root on both sides, square root of a minus 1 squared, that's simply a minus 1, and the square root of 0 is 0. So I have a minus 1 is equal to 0, and if I add 1 on both sides, I get a is equal to 1. Now remember how we set a equal to x plus 100, so this means that 1 is equal to x plus 100, and x is equal to negative 99. So now to check, if I plug in negative 99 into my original equation, I get negative 99 plus 100 squared is equal to 2 times negative 99 plus 199. So negative 99 plus 100 is 1. 1 squared is 1. So I have 1 is equal to 2 times negative 99, which is negative 198 plus 199. And 199 minus 198 is simply 1. So I get 1 is equal to 1. And because this is correct, my solution is correct.